we started talking about probability in the last class. And does anybody have any doubts with respect to what we talked in the last class? What is the basic reason why we are learning probability, or how you get your head around the basic calculation of probability? Is that part clear to you guys, or there is still something that is bothering you? Everybody okay? So Arav has two alternate emojis that he uses very often. First the crying one, then the thumbs up one. Okay. So what we are going to do today is this. Let me try to recall. I myself forgot what was in the agenda. So we'll talk about sample spaces for compound events and then probability of compound events. So last class we just talked about probability of individual events. We talked about when you flip a coin, what is the probability of getting head or tail? And what does probability mean? How do you define probability as a ratio of number of concerned events versus total number of events? Now we are going to talk about, or relook at, what is sample spaces one more time, and then we will talk about what do we mean by probability of compound events, meaning when multiple things are happening together. What do we mean by that? How do we relate to it? And how do we use our mathematical ability for dealing with them? So let me do a quick roll call and see who all are here. So we have Sami, Arihan, Vedant, Ved, Vasundhara, Thiru, Swari, Nihan, Dikshita, Milana, Adrik, Abhi, Aryahi and Arav. Alright, so let's get started. So what exactly do we mean by sample spaces? Anybody? Can anybody help me recall what is sample spaces? Yes, Arav.
It's like the favorable and the total number of outcomes you get during before or during a probability experiment. Like for example, theoretical probability, experimental probability.
Theoretical, experimental probability I have not talked about. I will not let you go that far. Give me a simplest possible definition of what do you mean by sample spaces. Yes, Arihan.
The odds of happening.
I'm sorry?
The odds of a specific thing happening.
Okay. Anybody else wants to add? And kids, can you keep your video on? I don't really feel comfortable with everybody being behind the scene and keeping their video off. Please keep your video on. There is no hide and seek game happening here, okay? Everybody, please. Yeah. This is better. Thiru, Swari, Arihan. Yeah. Yeah. Everybody keep your video on, okay? I mean, I know I'm being little flexible with that, but I feel that's not a very good strategy. Okay? When we are trying to learn together something, be in front of me. I mean, the ideal thing would be everybody in the classroom, but it's okay, understood. Not everybody can be in the classroom. I certainly cannot ask Thiru and Swari to be in the classroom. They'll have to take a flight for being here. So the case with Ved also, and Arihan too. But yeah, coming back to this one. Sample spaces. Now, let me give you guys some lame examples to make it much easier and smooth to digest. If I am talking about tossing a coin, a fair coin, which can either give me a head or it can give me a tail. This is what I will call a sample space for this particular event. If I am rolling a die which has 6 sides into it and has numbers imprinted from 1 to 6, what is my sample space? 1, 2, 3, 4, 5, 6. Sample spaces are nothing but it tells you all the possible events. And when you talk about probability within that, you are talking about a subset of it. So if you guys remember the first class when we started talking about probability, we said okay, probability of anything happening is nothing but number of concerned or relevant event by total number of events. So here, this is my sample spaces. This is total number of events that will come here. If somebody says, find out the probability of getting a number more than 4. So for that case, probability of getting a number greater than 4 is how many? This or this? Only 2. Out of the sample spaces, 1, 2, 3, 4, 5, 6. That's it. So sample space is nothing but it tells you that this is your entire set of data that you are looking at. Does it make sense? Yeah? So, I'll be very honest with you guys, okay? When I came across this term sample spaces, 35 to 38 years ago, when I was reading it for myself, there was nothing called sample spaces. I just knew that okay, total number of events is my denominator, number of the event that I'm talking about which is of concern, that will be our numerator. I didn't know this is sample spaces. So when I was talking to you guys, when I was planning to teach you guys, that is when I thought, okay, let me make it something similar to what you guys are used to hearing or what you would hear more often in your school. Okay? So that's the whole thing. So sample space is nothing but it's a complete set of data or the events that you're looking at. Yeah? Now let's go further from this one. So we know what is probability. Probability is number of concerned event divided by total number of events, and total number of events is coming from sample spaces, which is my comprehensive list of events or possibilities. Yeah. Now when we talk about compound probability or combined probability, so now let's look at it. Let's say I have to, let's say, buy a car. I mean, I have no plan of buying a car, but let's assume that I have to buy a car. And I'm choosing between Toyota, Honda, and let's say GMC. Okay? And then I'm contemplating between, see, I'm getting a little funky with my plan. So I'm trying to choose between violet, pink, and yellow. Okay? So, or let's say I have decided on these 3 models or brands, and Toyota offers violet, pink, and yellow. Honda also offers violet, pink, and yellow colors, and GMC also offers violet, pink, and yellow. I'm thinking, what is the probability of me leaning on buying a yellow GMC? You're not thinking? Alright, I'm still thinking. Okay, go ahead. Alright, go ahead. Unmute and talk.
Oh, 160.
So, my sincere request to everybody would be, remember this, there is a reason why brain is kept at the top and mouth comes underneath. So think and talk. Don't rush. Giving a wrong answer in a hurry doesn't take us anywhere. Yes, Thiru.
1 and 9.
Okay, Hariha?
I'm also wondering, but if you didn't pull 100%, you would have to figure out how many, like, if you wanted a DMC
Or you not forgot that his teacher is not intelligent. I'm not able to follow you, but you told a lot of things and I could barely catch it.
It's basically this book.
1619. Okay. I will do that in my simple way and then we'll try relating to it. Okay. Yeah, wait. What is that is coming to your mind? 19. Abhi? Okay. Thiru, you want to put your hands down? You have already shared your answer. Dikshita? Sorry. Nihal? Okay. Now let me get you all tired and bored of me. That's my plan for today. See, there are different ways I can think about it. I have too many options. First thing where I am wrapping my head is that okay, I have 3 brands to choose from, and then every brand comes with this many options. So how many options do I have? I have Toyota Violet, Toyota Pink, Toyota Yellow, Honda Violet, Honda Pink, Honda Yellow, GMC Violet, GMC Pink, GMC Yellow. Now, there are different ways I can visualize it. And here, you guys gave me the answer, and I'm not saying that is wrong. But when this gets more complicated, that is where this grid understanding or the tree structure derivation would help us in a great way. Now let's look at it. If I look at this like a grid, I'm saying okay fine. I have total how many options? Honda Violet is one option, Honda Pink is another option, Honda Yellow is another option. Sorry, Toyota is a Toyota. This is a Honda, same thing. So I have total 9 options and saying that what is the probability of getting a GMC Yellow is only 1. So 1 out of 9. This is one way of looking at it. Now second way of looking at it would be, ultimately it will come to this formula, okay? Probability equals number of concerned event by total number of events. Total number of events. So knowing all the total number of events is very important, and then knowing what exactly you are concerned about, that is also important, and that is how you plug into the formula. One thing was this approach where you put that like a 2-dimensional matrix. I mean, I started the whole discussion with this grid and I showed it here. But when the question comes to you, it will say, okay, Toyota, a customer is planning to buy a car between Toyota, Honda and GMC, and every car company offers this many combinations, these colors. What is the probability of getting a GMC with yellow? Or if they want to tweak it a little bit, say okay, what is the probability of getting a Honda but not violet? As soon as that changes to Honda but not violet, meaning we are talking about this and this both possibility. So 2 is the total number of events, of total number of concerned events divided by 9. That will be your probability. This is another way of looking at it. Another more intuitive view is you will use a tree structure, and that will clear a lot of dust also. You will say, okay, Toyota is my first tree, second tree is Honda, and third one is GMC. Each gives me 3 options: violet, yellow, and whatever it was, green. Violet, yellow, green. Violet, yellow, green. And then you'll say, okay, fine. My combination is Toyota violet, Toyota yellow, Toyota green, Honda violet, Honda yellow, Honda violet, Honda yellow, Honda green, and GMC violet, GMC yellow, and GMC green. this became your sample spaces, and you will count how many elements are there, and that's it. So, not always and you will say, okay, fine, out of this many, I'm talking about Toyota, let's say green. This is one out of this many. If somebody says, okay, what is the probability of getting Honda not yellow? So you will say, okay, fine, Honda not yellow is Honda but not yellow. So Honda green, violet or Honda green, these are the two branches. So 2 out of this many. So you have to start visualizing it that way, and there's much more interesting formula that will come across. Okay, not maybe in this grade, but probability is something which gets very intense in the high school. You will start relating probability with permutation, combinations, and all those fancy stuff. Okay, so right now we are just laying the foundation for how we want to digest and interpret probability in the simplest possible way. And then it will get more interesting as we go. Yeah. But here, why I was calling this as a compound event, because it was, if you compare this with initial situation when we were talking about rolling a dice or flipping a coin. These were independent. When you are rolling a dice, first time you're getting first 1 or 2 or 3 or whichever number, that has nothing to do with the other numbers. They are independent, and this is only one event by itself. Here what's happening is, these are combined. You cannot have a Honda and Toyota together in the whole calculation. Basically, we are talking about a combined outcome. We are not talking about only Toyota or only Honda. We are talking about Honda and violet. We are talking about GMC and green or GMC and yellow kind of thing. So this event of selecting a car brand and event of selecting a color is coming as combined thing. That's why it is called compound probability. Okay, it cannot be, the color selection cannot be looked at in isolation. Neither the brand selection can be looked at in isolation. Yeah, that's why it's called compound. So let's look at some problems. I think that will clear the dust and make it much more clearer to relate to. Is everybody okay so far, or was too much to agree to? Everybody okay? See, when I'm seeing Thiru's face, at least I can be sure that at least Thiru is okay with whatever I have said. That's the motivation for asking you guys to keep your video on, okay? It becomes easy for me. I don't call out names. Milana, Sani, Ariyahi, everybody okay? Okay, got it. No, I understand. I mean, there are technical problems as well, but yeah. Okay. You did not understand. So, now let's look at a very simple thing. If I'm tossing a coin, a fair coin, which has head on one side and tail on the other side. So, if I'm tossing it, what is the possibility or probability of getting a head? It is 1 out of 2. Okay? Because the total number of things that can occur is head or tail. So that is called sample spaces. That is the total number of events. Okay? And I'm talking about finding out probability of getting a head. So I can get a head or I can get a tail. This is called my sample spaces. There are 2 events, 2 likelihood, 2 things that could happen. And I'm only concerned about head. So probability is calculated as total number of events that I'm concerned about, which is only head, only 1 out of 2 possible chances. 1 by 2 is my probability. Now, if I'm rolling a dice, which can give me a number from 1 to 6, and somebody says find out probability of getting 3. My sample spaces are, or number of all the events are 1, 2, 3, 4, 5 and 6. I'm talking about, so if I plug in this formula, probability of getting a 3, probability of 3 will be what? 1 out of how many? 1, 2, 3, 4, 5, 6. This will be my probability. So these are simple events. Okay, then one thing is done, and based on that you can find out the probability. Here, but before I go to compound event, is this part okay, Sandy?
Yes, sir.
Okay. So now here I rolling a dice or flipping a coin. These were like one event on itself. Here, when we talked about this car and color combination selection, there are two things. One is the brand, second is the color. If I go from color, okay, I will say, okay, fine. I will put this as violet, yellow and green. With violet, I can have Honda, Toyota and GMC. With yellow also I have 3 options, Honda, Toyota and GMC. With green also I have 3 options, Honda, Toyota and GMC. What is happening is you are not looking at only brand, you are not only looking at color. There are two things together which we are taking into account to calculate probability. That's why it's called combined probability or compound probability. That's what I've said. Is that okay? Is everybody okay? Sami, Noah, Dikshita, everybody? Vedant? Okay. So now it's time for us to actually look at some problems. Because if you don't look at the problems, we would not know what is that we don't know. Or only good news for you all is right now we are looking at the simpler version of probability. Okay, so it's very important for us to relate that in very easy, relatable way rather than relying on any complex formulas. Okay. So let me read one question for you guys, and I will rush to get some headache medicine. I'm getting headache a little bit. Let me read this question, and I will let you guys think through it, and I'll be back in 30 seconds. You are picking out water balloons. Hear me carefully, okay? You are picking out water balloons. There are 3 colors and 2 sizes. 3 colors and 2 sizes. If you randomly pick the color and size, which of these diagrams can be? Oh, I did not put the diagram. Okay. Let me start with the easy one. Okay. Let me start with the easy one. If you flip 3 fair coins, what is the probability that you will get a tail on the first flip, head on the second flip, and another tail on the third flip? If you flip 3 fair coins, you have three fair coins, or you are flipping one coin 3 times. It says what is the probability that you will get a tail on the first flip, head on the second flip, and another tail on the third flip. Tail, head, tail. You are flipping it 3 times. Tail, head, tail. You are flipping a coin 3 times. You have to find out the probability. What is the probability of getting tail, head, and tail in the 3 flips? Think about it. I will be back in 30 seconds. What did you guys get? Yes, Vasudha, what did you get? Vasudha, I cannot hear you with that. 1-8. Thiru?
I also got 1-8.
1-8. How about Abhi?
Can you repeat the question?
The question is, you are flipping a fair point 3 times. What is the probability of getting a tail in the first flip, head in the second flip, and tail in the third flip? You got the question? Yes, Advik, what did you get?
I got 1-8.
1-8, Arab,
I got 1-8.
Alihan,
Failure.
1-8, Aryahi,
I also got 1-8.
Ikshita,
1-8.
Abhi.
1-8.
Okay, so everybody got 1-8. So you guys are on one side and I'm alone. I have to see whether I can agree with you all or I have an opportunity to not agree with the right reasoning. Swari, Ved, Vedant, what did you guys get?
I got 1-8.
Okay. How about Ved and Vedant? Ved is thinking?
I got 1-8.
So you also got it. How about Vilana?
I'm a little bit confused, but like in the end I
Got one right. So let me break it down to very simple. Whenever you're dealing with probability, right, you always have to do. See, there are only 2 things that you have to do. One is what is the event? What are those events that I'm concerned about? By total number of possible events. That ratio will give me the probability that I'm looking for. So now I have a coin and I'm flipping it 3 times. So let's see what I can get in the first flip. I can get a head or I can get a tail. Okay? First flip can get me a head or tail. Second flip, okay, I can get a head or I can get a tail. Now, second flip has no bearing with what has happened in the first flip. So I can get a head. Let me do it step by step. Okay. So when I am getting a head in the first flip versus a tail, I can get a head or I can get a tail in the first flip. Now for every head, second flip I can get a head or I can get a tail. When my first is head, second is head also, third could be a head or it could be a tail. So look at this, what I'm doing. First is head, with a head I can get a head or I can get a tail. With first being head, first and second being head, I can get a head or tail. Okay? So first and second being head, I can get a head or tail. These are the first 2 things. Now let's come to this. When my first is head, second is tail, I can get a head or I can get a tail. My first one is head, second one is head, third one can be head or tail. So these are 2 for first and second being head. If my second one is tail, then also I can get a head or tail. Now this whole thing repeats when I flip my first one to tail. tail, tail, tail. You'll see the same combination. First one is tail, then is head. With this combination, you can get a head or you can get a tail. When this is not head, second one is also tail, then also I can get head or tail. So basically you have to just look at all possible events. Okay, when first one is head, I can get a head or a tail. When first one is, second one is head, I can get the third one as head or tail. So head is done, head, tail is done. Now I'm switching to second one. Or look at it simple way. First word head, you can get a head or tail. Okay, fine. My second one changes to tail. So head and tail combination. Third one could be head or tail. Now this whole thing will get doubled when I change my first one's outcome to tail, and then do the same thing. First one is tail, head, tail. First one is tail, head, tail. So this gives me total number of events. And right now we are doing it in a manual way. After some time, once we go a little deeper into it, we'll start doing a more calculated way, more formula way. Okay. So this gives you total number of events. Total possibilities are 8. What we are concerned about? What is the possibility of getting a tail, head and tail? Tail, head and tail. This is, and again we are very particular about it. We are saying first one is tail, next one is head and tail. Do you see anywhere where you have the same sequence, tail, head and tail? No, there is only one. So your probability is number of concerned event, which is only 1, divided by total number of events, 1, 2, 3, 4, 5, 6, 7, 8. Is this what you guys also did? Or you guys did something different? Arihan has raised his hand. You want to say something, Buddha? Okay. Now, what I want to do little differently here. This was a very manual way, and good that we are only talking about tossing a coin with a head or tail. And then if I have to find out, I could still do it. Imagine this becoming 20 flips. If you are doing 20 flips, imagine how much of paper I have to use just to determine how many events I am talking about. So let me give you guys some method to the madness, and you'll probably find this thing interesting. So here, finding out the number of events which are of concern is much easier because you know which event you are talking about. But what is the total number of events? That is where it gets very interesting. And the concept behind is, how do you find it out? Let's look at it. If I am doing, let's see if I have only one flip, okay? So what are the things I can get? I can get head or tail. So I am talking about 2. If I am doing 2 flips, I can get head and tail, head and head, tail and tail, tail and head. Correct? So earlier with one coin, with 2 possibilities, I got 2 options. With one coin, 2 coins, every coin with 2 possibilities, I got 2 into 2, 4 options, or 2 into 2 options. Now if I increase that to 3, what is happening is, I am saying, okay, head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. Every coin had 2 options. Every coin had with one coin we got 2 options. Total number of events. When we put 2 flips or 2 coins we got 4 options, which is 2 into 2. When I put 3 flips, it became 8, which is nothing but 2 into 2 into 2. So next time if I say I'm doing 5 flips, you will say, oh, 5 flips, meaning 2 is getting multiplied by itself 5 times. That's it. So total number of events will be 2 into 2, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. That's it. You will not do that dirty job that I was doing. And this works as a strategy when you are talking about independent events. Meaning, first one getting head versus second one getting head or tail has no linkage. If your first one is head, you don't care about what has happened the first step when you are flipping the second time, because there is no linkage, there is no guarantee. It doesn't say that, okay, you have got head already, so next time you can only get tail. There is no linkage between the two. Does it sound okay? It was not worth clapping, but there. Question was, does it make sense to everybody? Milana, Thiru, sorry, everybody. Now, look at the more interesting part of it. Now, if I say that I rolled 2 dice, okay, which has numbers written from 1 to 6. Or let's say I rolled 2 dice, which has numbers written from 1 to 6. What is the probability of getting 2 in the first roll and 5 in the second roll? How would you calculate this? I rolled 2 dice, which has numbers written from 1 to 6. What is the probability of getting 2 in the first roll and 5 in the second roll? Let's see how you guys are thinking about it. Is everybody trying it? Okay, go for it and let me know once you are ready to share something. See, everybody turns off the video as soon as I forget about it. Vedant, Milana, what is happening? Are you able to try? Yeah, okay. Vasundhara, Ved, everybody, you want to try? Ved is thinking, I can see him think. Yes, Vasundhara, what did you get? I am rolling 2 dice which has numbers imprinted from 1 to 6. And again, it's a fair dice, okay? We cannot manipulate it. So my question is, what is the probability of getting a 2 in the first roll and 5 in the second roll? Yeah? Yes, Arihan.
136.
136. Okay. Alright. Let's see what you got.
I also got 136.
Okay. I will let everybody spend 2 more minutes and then I will outsource my work to Thiru or Arihan to explain that to everybody else. Yes, Ved. I could not hear you.
1/36.
Okay. Arif?
Total of 1/36.
Okay. Mr. Nihan, you have not given me any answer today. I want to hear your sweet voice as well. Yes, Advik.
About 4/36.
Say it one more time.
4/36.
Okay. Okay. Just because we have only 15 minutes left, I would want Thiru to explain to everybody why he thinks 1/36 is the right answer, and then I will let Advik also to explain why he thinks it's 4/36. Okay? And then I will add my 2 cents. Yes, Thiru, go ahead.
I think it's 1/36 because when I did first was still, since there's 6 like numbers you can get, and the first number was 2, that's like 1/6 of a chance to get a 2. And
Okay.
then the second time, it's also 1/6 chance to get 5. And then what I did was I multiplied 1/6 times 1/6, and I got 1/36.
Okay. Let's see why Advik thinks 4/36. Tell everybody your story, Advik.
So, like we have 2 dice, right?
Mm-hmm.
And we're trying to see what were the probabilities of. Oh, wait, I said my mistake.
Okay. So 1/36 is the right answer. That's what I believe and I feel, but my feelings are not important. Let's do it mathematically. So we will relate it back to the same approach that we were doing, right? With the tossing of the coin, where every time I toss a coin, I had 2 options. Here, every time I toss a coin, roll a dice, I have 6 options. When I toss the coin twice, I had 2 into 2, this many options. When I roll the dice once, I had 6 options. When I roll it one more time, I'll have this many options also. And you can relate to it. For every number on the first one, you can get 1, 2, 6, meaning 6 options. When it becomes 2, you can still get 6 options. When you get 3 here, you get 3 options, 6 options again. So for every number here on the first dice, you can get 6 options. So 6 for 1, so 36 for 2. Or you can relate to this formula also. So total number of possible events are 36. We are talking about specific situation, getting a 2 and a 5. Getting a 2 is 1 out of 6 that you can get in the first row. Once you have nailed it down to 2, you are only left with 6 options, and out of those 6 options you have numbers ranging from 1 to 6, and you are very particular about choosing only 1. So this is the only combination you can think of. Only combination you can think of. So this is one possibility out of the total number of possibilities that you are getting from here. If I twist this question a little bit and say I am rolling 2 dice, what is the possibility of me getting more than 8 by rolling on 2 dice? Go for it. This is the last question. Again, the same question I am saying, I am rolling 2 dice. What is the probability of me getting more than 8? Yeah? Find it out. Everybody heard the question, right? Advik, Arav, Milana, Dikshita, Abhi, Aryahi, Nihan, Thiru, sorry, everybody, right? Ved, Okay. I'll repeat one last time and I will go quiet. I'm rolling two dice which have numbers imprinted from 1 to 6 on it. What is the probability of me getting a number more than 8? Jump onto it. And there's a reason why I'm giving this question, okay? You will see a different flavor a little bit. Again, not trying to confuse you guys, but this is complicated. It's not complicated. It will just make you think a little differently. Arav, don't be a crybaby. Do it. Ved is doing some magic with fingers. Yes, Abhi.
May I have a question?
So I'm rolling two dice, and the dice have numbers imprinted from 1 to 6 on it. What is the probability of me getting a number, a sum of the two numbers, sum of the numbers after rolling to be more than 8? Is that clear? Abhi? Yeah, okay. Yes, Abhi. What did you get?
1/2.
1/2. Okay, what did Arihan got?
536.
Say it one more time.
536.
536. Okay. Abhi.
I get my answer to 536.
Okay. How about Vedant, Sami, Milana, Ved? Sorry, what's happening? What did you get to do this time? Thinking?
Yeah, I'm still thinking.
Okay. So, Sami, are you able to do it right now?
No, sir, not really.
Okay. I'll explain that, don't worry about it. These are practical problems, right? I have grown up enough already. For you guys, when you guys are growing up, right? These are things that you will see, right? Rolling a dice, tossing a coin. Yeah, Vasundhara. What did you get, Vasundhara? 10 over 36? Wonderful. I love it. This is called unity in diversity. We are all united together. Dikshita, what did you get?
I also got 10 over 36.
Okay, so Vasundhara is not alone. She got some support. Let's see. Anybody else? Arihan, Vedant, Nihan, Swari, Aryahi, Milana. It's already 5:53. So in 7 minutes I'll disappear. I want to make sure that I don't disappear with everybody being confused. Mr. Arav, I need your smiling face with an answer, not the crying face. Okay, so let me do this. What did you get, by the way? Lana? Okay, so let me try doing it for everybody's benefit. Okay. What does the question say? Question says that we have two dice that we are rolling, and that every dice has 1 to 6 imprinted on it. Yeah? So when I roll the first dice, I can get from 1 to 6. Okay? Now for every number on the first one, second one again can give me options from 1 to 6. Correct? When I roll the first dice, I can get anything from between 1 to 6, right? And for every number of this, when I roll it the second time, I can get again anything from 1 to 6. So for every number I have 6 options. Every number on the first dice has 6 possibility on the second one. Is it okay, Samuel, so far? Yeah?
Yes, sir.
Okay. So when I'm rolling the 2 dice, I can get on the first one I can get any number from 1 to 6. And since we're talking about possibilities, right, anything could happen. So when I'm getting the first one I can get anything between 1 to 6. So there are total 6 possibilities of this combination. Where first possibility is 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. 6 options. Same thing here, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. 6 options again. Same story repeats for 3, same story repeats for 4, same story repeats for 5, same story repeats for 6. So for every number I have 6 options. Every number on the first roll has 6 options. So essentially I'm talking about 6 into 6, 36. Or like the way I explained the coin thing, every roll has 6 options. I'm doing 2 rolls, 36. So this is my sample spaces. So if I put that in this, repeat this in form, I'll say okay, 1 comma 1 is one option, 1 comma 2 is second option, and it will go on till 6 comma 6. Total 36 options. This is my sample spaces. So when I'm calculating probability, I'm talking about total number of options is 36. Now what is my concern? What is the thing that we are trying to find out? We are saying what is the probability of getting sum of the 2 numbers from these rolls to be more than 8. And to be more than 8, so I'm talking about 9, 10, 11 and 12. These are 4 scenarios. Now how I can get 9? I can get 1 with 1, nothing will get me 8. So I will completely rule this out. This 6 is gone out of my scene. 2 up to 6. 2, 1, 3, 2, 6, 8. I have to get things which is more than 8. So this set also I ignored. I came here. In 3 case, till 3 plus 5, 8 is excluded. This doesn't give me what I'm looking for. It has to be greater than 8. I only get 3 and 6. 3 and 6 gets me more than 8. So this is my first combination. This is number 1. Then I go to 4. 4, 1, 4, 2, 4, 3, 4, 4 gets me only up to 8. I'm not even concerned about that. I'm looking at 4 and 5, 4 and 6. That is only 4, 5, 4 and 6. These 2 combinations will only get me something more than 8. So this is 2. Now come to this guy. 5 to 3. 5, 1, 5, 2, 5, 3 gives me up to 8 only. I'll exclude this part. And then this 3. So 5, comma 4, this combination, 5, comma 5 and 5, comma 6. This 3 combination gives me the desired situation. Now come to 6. 6, 1 and 6, 2 you will ignore because this 2 will give you up to 8. 6 plus 1, 7, 6 plus 2, 8. You will exclude this part and then you have remaining 4. So I am putting 4 here. Okay, I am not writing it just to save time for everybody. So how many combinations are relevant for me from all this set? 1 plus 2, 3 plus 3, 6 plus 4, 10. 10 out of how many? 10 out of 36. Or If you want to simplify, it becomes 5 over 18. Did that make sense to everybody? Not really. Thiru, I see you are trying to believe what I did. Still not convinced. Now, unmute yourself and tell me what is your observation. I'll correct it if needed. Yeah.
I'll really get it, but
No, so let see, it's okay. I'm okay to spend 2 minutes extra with you guys, okay? See, always, I never want to end the class with my case being confused, so I'll just do it one more time. We are rolling 2 dice, correct? Let's say in the first roll I can get anything from 1 to 6, yeah? Now for every number on the first roll, I can get a corresponding 1 to 6, so that for first number being 1, for the second roll, I can get up to 6 options. Yeah? So there are 6 options here, 6 options for number 2, 6 options for number 3, 6 options for number 4, 6 for 5 and 6 also. So total number of events is 6 times 6, 36. Yeah? Now the question was, what is the probability of getting a sum of the 2 numbers after rolling the dice to be more than 8? Now we are looking at these sets. First one I got 1, 2, up to 6. Any number here, this combination doesn't give me 8. So first set I excluded completely. Now I came to this set. Here with 2 also I can get anything from 1 to 6. But last number, the largest number, 2 and 6 also is 8 only. I need to get something more than 8. So I excluded this set also. When I come to the third set, where first one is 3 and the numbers are from 1 to 6, 3 up to 3 plus 5 gives me 8. I'm not really interested in that. I'm looking for things when it gives me more than 8. So 3 and 6 gives me 9. So in the combination of 3, I got 1, 3 and 6. This is one combination. When I go to the fourth set, which is starting with 4 in the first row, up to here I will not count because 4 plus 4 gives me 8. Anything less than that is not of interest for me. 4 plus 5 gives me 9, 4 plus 6 gives me 10. So with the set of 4 I get, so with set of 3 I got 1 valid scenario. With set of 4 I got 2 valid scenarios. With set of 5 I am getting, if I am coming to 5, up to 3 I will not count, but anything after 3, 5 plus 4, 9, 5 plus 5, 10, 5 plus 6, 11. So there are 3 combinations that is relevant for me. When I come to the set of 6, 6 plus 1, 6 plus 2 is not relevant for me because 6 plus 2 is 8. Anything before that I will not count, but I have 4 sets, 4 combinations. 6 plus 4 is, 6 plus 3 is 9, 6 plus 4 is 10, 6 plus 5 is 11, 6 plus 6 is 12. So there are 4 scenarios that is relevant for me. Combining them all, 4 plus 3, 7 plus 2, 9 plus 1, 10. These are 10 valid scenarios in which my roll of the 2 dice is giving me anything more than 8. So this is 10. 10 is the concerned event, number of events, divided by total number of events. That is how I got my probability as 10 over 36. Does it sound reasonably okay to everybody?
Yes, sir.
Yes, sir.
Yeah? Many of you got the right answers already. I have no shame in acknowledging, like always, that I'm not very intelligent. I always look at breaking it down. Like practically, if I'm playing with the 2 dice, how would I look at it? Right? That's a more practical way of looking at it. That's why before I jump into any formula, I look at it in a very simplistic way, because if I can digest this, relating that will be much easier. Yeah? With that being said, Milana, are you clear with that? Milana, Nihan, sorry, Ved, Vedant, Sammy. I called out the names who were more quiet today. That's why I called out the name, just to give assurance to myself that okay, my kids are with me. Alright? Are you okay? I already dropped off. She got tired and sick of me. Okay, alright, have fun guys. See you guys tomorrow, same time.
Bye, sir.
Thank
Bye
you,
bye.
sir.
Bye bye. Bye bye.